Who is this actually good for? Who should skip it, and is it worth the price for a normal everyday buyer? If you're the sort of person who has already maxed out a 16GB kit and are starting to feel the pinch when juggling a 4K video edit, a high-end game mod, or a handful of virtual machines, then this memory set might feel like a logical next step. On the other hand, if you're mostly browsing, streaming Netflix, and doing the occasional spreadsheet, you'll probably find a cheaper 32GB kit does the job just fine. Link is in the description if you want to check the product details on Amazon. The biggest hesitation I see people have when they stare at a 64GB DDR5 kit with RGB lighting is the fear of spending a premium on something that sounds flashy but doesn't translate into a real-world benefit. The first thing I asked myself was, will my current workflow actually notice the difference between 32GB and 64GB? And between a 4800 MHz stick and a 5200 MHz stick? I dug through a handful of forums, looked at a few benchmark videos, and asked a couple of friends who run heavy simulation workloads. The consensus was clear: the jump in raw frequency does help when you're pushing the CPU hard, but the benefit flattens out once you have enough capacity to keep all your data in RAM. That's why the decision really comes down to two questions. Do you regularly max out your memory bandwidth, and do you need the extra headroom that 64GB provides? Let's start with the kind of builds where this kit shines. I have a friend who runs an AMD Ryzen 9 7950X with a 2TB NVMe drive, and he's constantly switching between a 3D rendering suite, a machine learning notebook, and a couple of Docker containers for development work. He told me that before upgrading, his system would thrash if the page file would spike, and he'd see a noticeable slowdown when he opened a new browser tab while the render was still processing. After installing a 64GB DDR5 kit, his RAM usage settled comfortably under 45GB, and the system stayed snappy even when he ran 4 heavy applications simultaneously. The onboard voltage regulation on this CORSAIR kit meant he didn't have to fiddle with manual voltage curves in the BIOS. The modules just took care of themselves, which is a relief when you're not a seasoned overclocker. The same kit also works well for gamers who want to future-proof their rigs. Modern titles are starting to use more memory, especially with ultra-high-resolution texture packs and ray tracing enabled. If you're playing at 1440p or 4K with the highest settings, the extra bandwidth from the 5200 MHz rating can shave a few frames off the most demanding scenes. It won't turn a mid-range GPU into a flagship, but paired with a strong CPU, it eliminates the occasional micro-stutter that you sometimes see when the game has to shuffle data between the CPU cache and RAM. The dynamic RGB lighting isn't just for show either. The lighting syncs with CORSAIR's ICUE software, so you can tie the color patterns to temperature or performance metrics, which adds a neat visual cue for enthusiasts who enjoy that level of feedback. Now, let's talk about who should walk away. If you're building a budget workstation or a mainstream gaming PC that will sit at 1080p, you'll likely never hit the memory ceiling that justifies 64GB. A 32GB kit with a modest frequency will keep the cost down and still give you more than enough headroom for gaming, streaming, and even occasional video editing. The price difference for this CORSAIR set is significant, and you'll notice it in the overall build budget. Additionally, if you're planning on using an older motherboard that only supports up to DDR4, or a motherboard that doesn't list this kit on its qualified vendor list, you could run into compatibility headaches. The kit is tuned for AMD 600 series chipsets and supports both AMD EXPO and Intel XMP profiles, but you still need a board that can handle DDR5 at those speeds. Skipping the research on motherboard support could land you with a set of sticks that simply won't boot at the advertised frequency. Practical strengths are where this kit earns its 4.5-star rating. First, the latency numbers 40404077 sit comfortably for a high-speed DDR5 part. In real-world tasks like compiling large codebases or loading massive datasets into a Python environment, that latency translates into quicker data fetches, which you can feel as a smoother overall experience. Second, the onboard voltage regulation means the modules stay stable without you needing an external regulator or a custom BIOS setting. That stability is especially important for users who run their machines 24/7, because you don't want random crashes caused by voltage spikes. Third, the RGB aspect is modular. You can turn it off entirely if you prefer a stealth build, or you can program it to pulse on load spikes, turning a performance cue into a visual one. On the downside, the kit isn't without trade-offs. The higher frequency comes with a slightly higher power draw, which means the overall system's thermals will be a touch higher than a lower speed.